let's talk about compound linear inequalities in two variables. So first of all, what is this, a compound linear inequality in two variables? So they are inequalities that look like this. So either this one here, where you have this inequality, but then you have the word and, or you have the word or, so one of those two, and then you have a second inequality. So this is what they look like, and we're going to talk about how to graph these and kind of how to work with them. So I'm assuming that you already have seen and worked with like and or before. If you haven't, I'm going to drop a link to a lesson that kind of warms up this idea. But let's just do a really brief refresher of what does the word and mean when you have compound inequalities. So when you see and, you want to focus on what is common or shared between the answers. And then what does or mean in compound inequalities? You really want to focus on like the culmination, the combination of the answers. So what I want to do here is I want to just jump right into an example. And so I've got two graphs here, and I'm going to show you how you can kind of go about this. So starting with y is greater than 2x plus 1. So first things first, we're just going to graph this, and really what we're going to graph is just y equals 2x plus 1. So if I start with that, so I'm going to graph this in this green color. So this has a y-intercept of 1, and then I can go up 2 over 1. See, up 2 over 1. So there's a couple of points that define that line. And so here's the thing to remember with this. With the greater than or the less than, so whenever you have less than or greater than, you use a dotted line. And if it's less than or equal to or greater than or equal to, you use a solid line. So with that in mind, this particular, like the shape of this line is going to require that we use a dotted line. So hopefully this is nice and clear. Okay, so let's see. Actually, let me get rid of this graph for a second. Okay, so what I've talked about with just graphing general linear inequalities is, so one side of this line will actually be comprised of like all the possible combinations that will make this inequality true. So if you don't know what I'm talking about with this, I will drop a link to that video because that's kind of like background information for this, and it takes a little while to explain that. So I'm just going to jump in and use it, but I will drop a link to that idea if you need a refresher. So anyways, so looking at this graph here, so I just really want to choose 2 points that are on the on each side of the line. So I'm going to choose the point 0, 0. And then let's see, I'll choose this point over here. So let's see, this is 1, 2. This is negative 4, 0. So I just randomly chose 2 points. All I care is that they are on opposite sides of the line. And now what I'm going to do is I'm going to plug each one of these points in to my inequality. So for this first one, for 0, 0, I'll get 0 is greater than 2 times 0 plus 1. And what I'm really curious in is if this is a true or false statement. So 0 is not greater than 1, so this would be false. But now let me compare that to negative 4, 0. So now I'm going to plug that in. So this is going to be 0 is greater than 2 times negative 4 plus 1. And this gives me, let's see, negative 8 plus 1. So this will ultimately say 0 is greater than negative 7. So this is true. And so this is what I talked about in the other lesson about graphing linear inequalities. So it's always going to work out that one side of this line is going to end up with a true statement and the other side will end up with a false statement. And the side that has the true statement, so this side here, this is the side that we really want to shade. Because this side, if you choose any point on this side, it will work in this inequality. Okay, so I want to clear a little space. I want to erase these old points. And I just want to very carefully kind of note what side of this graph that I want to shade. Okay, so here's the first graph. Okay, so now what I want to do is I want to just hold this idea for a moment. And let's start over and let's focus on this one now. So let's just get a clean slate. Okay, so now what I'm going to do is I'm going to pivot and I'm going to graph this equation here with this orange. And again, this is in that slope-intercept form, so we can easily graph it. So this has the y-intercept of negative 3, and then the slope of negative 1, so I'll go down 1 and to the right 1. And okay, now this is a less than or equal to sign. So what that means is that I want to just use a solid line to connect these points. Okay, and so there we go. And so now I want to figure out what side of this line do I want to shade. Now, I'm going to choose the origin just because it's always one of the easiest points to do calculations with. And then I'll choose this point down here. So let's see, this is 1, 2, 3, 4, 5, 6. This is 0, -6. So now what I'm going to do is I'm just going to figure out which side of this particular situation am I going to shade. So starting with 0, 0. So I'm going to take 0 is less than or equal to -0 minus 3. So this says 0 is less than or equal to -3. That is false. So hopefully my other point is true. You do always want to plug in both points because you want to make sure you didn't accidentally do the math wrong. You should never have that both sides are true or both sides are false. Okay, so I've got this. So this is going to be -6 is less than or equal to 0 minus 3. So -6 is less than or equal to -3. That is true. So what that means then, I'm going to go ahead and clear this off. And I'm just going to kind of shade down this way, like so. Okay, so I've graphed both of these inequalities separately, and I'm going to kind of walk you through like some of the finesse with this, I guess. So let me bring back the other situation now. So here are both graphs, and then just as a reminder, so this one goes with this color goes with this line, or this inequality, this color goes with this inequality. So the idea with and is that you actually want to find kind of where these two answers overlap. So it can be a little tricky in how you're going to actually do this when you have an and type problem. So I wanted to start by showing you just what both graphs look like. And now you might want to think about how can you figure out the best way to kind of mesh these two answers. To me, what I actually like to do, I don't like to draw two separate graphs. I actually like to put both graphs on the same graph, but it's going to look a little bit visually dizzying. So what I'm going to do is I'm going to redraw the green graph. I'm going to draw it right here. So let me just very quickly do that. So there's that point, and then we said it was dotted, and I already know what side to shade at least. Okay, so this was the side that I wanted to shade. And so the whole point of this is that you're trying to figure out where is that area of intersection. And now I can see by looking at this that where these two answers intersect, it's like this little triangle right in here. And so that would be the actual answer. So all of this other stuff, this shading, is not part of the answer. So what you would want to do then is after you kind of do this work to figure this out. So let me clear off this graph now. Okay, and so now I have this clean, fresh graph where I want to just represent what the final answer actually is. So just one more time here. I'm going to sketch both of these lines together on the same graph, like so. Okay, so I've got both lines here now. And I know where they intersect now, right? So the final answer would actually look like this. So you're really just interested in that part where they overlap. So you can see that the work to get there can be a little bit tricky. And I think everybody has to kind of develop like their own system of how they're gonna represent this and not get confused by this. So for me, I've always been okay with just graphing everything together on the same graph. But I've noticed that a lot of times people get really lost in the work of staring at all of this. So a lot of people actually like to create the two separate graphs and then kind of figure out where they should intersect and then draw the final answer. And no matter what, you should always draw the final answer. So these kind of have a little bit of finesse and work involved with them. So take your time. Okay, now I just showed you how to do an and problem, which is a little bit tricky because you have to figure out, where they kind of share the shaded portions. So now I want to show you what happens when you have an or problem. How does this work? So, and actually, as I show you this, I'm going to show you another way that you can kind of approach the graphing, which you might find very helpful. So let's take a look at this. So where I want to start, I want to graph this line, y equals negative 2x plus 1. Let's start with that. So I've got this y-intercept of 1, go down to over 1, and then this is a less than or equal, so this will be a solid line. So there's the line there. Okay, now what I want to do right now is I just want to figure out which side should I shade, but I don't want to actually shade it. I'm just going to make some notes for myself, and then I'll decide what to do with these notes at a later point. So I'm going to choose 2 points. I'll choose 1 point over here, and how about this point here? So remember, the whole idea behind this is one side will be true for the whole side, and the other side will be false. So you just randomly choose whatever 2 points as long as they're on each side of the line. So starting with negative 1, 0, if I plug this in, I get 0 is less than or equal to negative 2 times negative 1 plus 1. So this is 0 is less than or equal to, this will really come out to 3. And that is a true statement. Okay, so this side seems like it's true. So just to be thorough, let me just make sure that this side is actually false. And so that is the point 2, 2. So if I plug that in, I get 2 is less than or equal to negative 2 times 2 plus 1. And so this will say that 2 is less than or equal to negative 3. So that is false. So this side does not have any points that work in this inequality. But all of the points on this side, if I choose any point at random on this side, they will all work in this inequality. So what I want to do here is I just want to note for myself which way I would shade. So notice that I drew these 2 little lines here. These are markers for myself, and I will decide what to do with them later. But this can be a way to kind of help you figure out what you actually want to do for your final answer. Okay, so I have kind of sketched out this line. I know what I'm doing with it. So I want to now pivot to the other line. So I'm going to use this goldish color. Same idea. This is still in that slope-intercept form, so I can go ahead and graph it. So let's see, it's got the y-intercept of 2. Then I'll go up 1 over 1. And this one has the greater than, so it's going to be a dotted line. So going like that. Because just as another reminder, less than or equal to or greater than or equal to gets the solid line. Less than or greater than, that gets the dotted line. Okay, so I've got the line here. And so this is where you have to just really pay attention. You want to ignore anything that happened with the green line for a moment. We are really just focused on this gold line. So I'm still just focused on this side versus this side. And so you can choose whatever points you want as long as you're on opposite sides of this line. So this right here, this is the point, let's see. This is the point 0, 4. And then this is the point 3, 0. So I'm going to plug each of these now into this inequality. So let's do it. So starting with 0, 4. So this will be 4 is greater than 0 plus 2. So that says 4 is greater than 2. That is true. So it seems like this side here is true. So let me just make sure that the other side is false. So now if I take 3, 0, this is going to be 0 is greater than 3 plus 2, so this says 0 is greater than 5. So that is false. So this side, if I plug any points in on this side into this inequality, they will not work. But if I plug any point in on this side of the line into this, it will work. So it will create a true statement. Okay, so now what I want to do is I just want to note to myself, this would be the side of the line that I would actually want to shade. And I can get rid of all this work. And now we can actually figure out what should I do for the answer. Now, this is very important. This is an OR problem. So I said with an OR type problem, you're basically combining all of your answers together. So basically any place that you would have shaded, you just shaded it all as one cohesive kind of shading. And that's your answer. Because this is an OR. That's different from an and. In an and, you're trying to figure out what do they share. With an or, you're combining everything together. So in this case, I've got all these little arrows. So I know I'm going to color all the way like this. Like this, like this, like this. And then I'm also going to color all the way here. So I literally just get all of it together in one spot. But you really want to make it clear that all of this is your answer. So I guess the method that I'm kind of showing you here, this is a way of how you can do everything on the same graph and wait until the very end to decide what you're going to shade. And so that would be your answer. Okay, so let's go through a few more examples here. And I'm going to show you once again how you can just use one graph to kind of help you draw your conclusions. So in this example, I have two equations. Now notice neither one of these are in that slope-intercept form. We cannot easily graph them. So I'm going to start with this first equation here, and I want to get it into that slope-intercept form. So I really need to solve this for y. So what I'm going to do is I'm going to just kind of go through the work of isolating for y. But I want to point something out as I'm going through this. So you know you need to divide everything by -2. But remember the thing about dividing with negatives and you have an inequality. This requires you to flip the direction of the inequality, and this will matter. So here's my situation now. So what I'm going to do is I'm going to note this here. And let me clear off the rest of this. And now I've basically made this a lot easier for me to graph. So I have this equation here, and so I've got a y-intercept of -3, so down 1, 2, 3. And then the slope is 3/2, so I'm going to go up 1, 2, 3 and over 2. And then do I do a solid line or a dotted line? Well, this is greater than, so this has no or equal to on it, right? So this is a dotted line like this. Okay, so now what we want to do is we want to figure out what side we would color in this case, or shade. So what I want to do is I'm just going to pick 2 points on each side of this line. So I'll start with 0, 0. And just as a reminder, so you can plug this into either form of this equation. You'll get the same result. So I'm going to plug 0, 0 into this form here. So if I do that, this is going to be 3 times 0 minus 2 times 0. So this says that 0 is greater than 6, and that's false. Now, in the event that you don't believe me, that, you know, maybe you're a skeptic, and I'm all for that, by the way. So maybe you want me just to prove to you that I'll get the same conclusion if I use the other equation. Let me just plug this point into this equation here. So if I do that, this will be 0 is less than 3/2 times 0 minus 3. So this comes out to 0 is less than -3. So notice it didn't matter which equation I put that point into. I still get the same conclusion of false. So I'm probably not going to shade this side, but now I just want to double check. So I'm going to choose a point on the other side. Let me get rid of all this. And so now I'm going to use this point, see, 1, 2, 3, 4, 0. So I'm going to plug this in, and I'm going to plug it into this because, like I said, it doesn't matter which equation I plug it into. So this will be 3 times 4 minus 2 times 0 is greater than 6. So let's see. This will give me 12 is greater than 6. That is true. So that means that this would be the side that I would want to shade. Okay, now here's the thing. I don't want to shade yet. Instead, what I'm going to do is I'm just going to draw these little arrows here so that I can visualize where I would shade, but then I'm just going to leave it alone for a moment. So now I'm going to pivot to this other equation, and I'm going to work on graphing this. So I need to get this into slope-intercept form, so I need to isolate the y. So I can just go ahead and subtract off the 2x. So I get y is less than or equal to -2x plus 3. And so this I can graph no problem. So let's see, y is less than or equal to -2x plus 3. Let me clear the rest of this. And now, okay, so I've got the y-intercept of 3, 1, 2, 3. Slope of -2, so down 2 over 1. And then is this a solid or dotted line? It would be solid. Okay, so there's the line. And so now I'm going to do the same thing. And I just need to choose a point that's on each side of the gold line now. So I don't even have to think about the green line for a moment. So I'll go ahead and choose the origin again, just because I'm lazy. And again, you can plug this into either equation, whichever one looks easier to you. So I'm just going to plug it into the first equation. So here's what that would look like. So this is going to say that 0 is less than or equal to 3. So that is true. So now let me just choose a second point. How about this point here? So let's see, that's 2, 3, 4. This is the point 2, 4. So I'll just plug that in. 2 times 2 plus 4, is that less than or equal to 3? Well, that'll be 8 is less than or equal to 3, so that is false. Okay, so now just by looking at this, I can see that this, so I just drew arrows in the direction of where I would shade. Okay, so let me clear all this work out. And now we pause for a moment to just think about the fact that this is an and problem. So and means I want to figure out where would these shadings coincide or where do they overlap. So in looking at this, I can see this little triangle here. This would be where the overlap is. This does not have green in it. This does not have gold in it. So this little triangle here, this would be the actual answer. So this is what I want to shade. And so then this is really how you can use one graph and, you know, just refrain from shading anything in, just make little notes on it so that you can figure out what the final answer would be. And the final answer is literally this part here that we've shaded. Okay, so for example B here, I want you to kind of do this alongside me, I guess. So let's start with this equation here. So first things first, I want you to get it into that slope-intercept form. Be careful when you divide. Watch out for if you have to flip the inequality. So figure that part out and just decide like which side you would probably shade and then hit play when you're ready. So in this case, so I've got 5x minus 2y is less than or equal to 10. So I'm going to go ahead and go through the work of just trying to solve for the y here. So as I go through this, notice I have to divide everything by -2. And in dividing by -2, I have to flip the direction of the inequality. Okay, so there's the equation that I want to actually graph. So this is y is greater than or equal to 5 over 2x minus 5. So let me clear the rest of this out. And now we can go ahead and kind of graph the line. So I've got a y-intercept of -5, 1, 2, 3, 4, 5. And then I go up 1, 2, 3, 4, 5, and over 2. Now do I use a solid or dotted line? In this case I'll use a solid line because it's the or equal to type sign. And now I just have to figure out which side would I actually shade. So I'm going to do the same thing I did in the last example. So here I'm going to just grab 2 points at random. So we'll start with 0, 0. Again, it doesn't matter where you plug this point in. You can plug it in into either equation. You'll still get the same conclusion. So if I plug this in, so I've got 5 times 0 minus 2 times 0, so is that less than or equal to 10? Well, that says that 0 is less than or equal to 10, so that is true. So it looks like I probably want to shade this side, but just as an extra check, I'm going to grab another point on the other side of the line. So this is the point 4, 0, so quick check here. So 5 times 4 minus 2 times 0, is that less than or equal to 10? Well, that'll say that 20 is less than or equal to 10, which is definitely false. So now I can confidently see that I am shading on the correct side. This would be the direction that I want to shade in. But I want to just hit the pause button here and pivot to the other equation before I go any farther. So let me clear this off. And now let's go ahead and actually, why don't you pause here and go ahead and try to graph this and decide which side you would shade on and then hit play when you're ready. So I need to get this once again into that slope-intercept type form so I can easily graph this. So I've got 6y is greater than -2x plus 12. Divide all sides by 6 to get y is greater than -1/3 x plus 2. So let me clear this all off now and I'll just note this equation that we want to graph. Okay, and so I've got a y-intercept of +2 and then a slope of -3, so I'm going to go down 1 and over 1, 2, 3. And then in this case, so I want a dotted line. So there's my dotted line. Okay, so same thing as before, so I need to just figure out which side am I going to shade. So I choose a point at random. I always try to choose the origin if I can. So I'll just plug this in. So I get 2 times 0 plus 6 times 0, so is that greater than 12? Well, that tells me that 0 is greater than 12, which is false. So I probably shade the other side, but I'll just check another point to be sure. So I've chosen the point 0, 4. So if I plug that in, I get 2 times 0 plus 6 times 4 is greater than 12. So I have 24 is greater than 12. That is true. So I can see now that I need to shade up in this case. So I'm just going to kind of note that. So once again, I draw my little arrows. Now, in this problem, we have an OR, and we know that the OR means that I just combine all the answers together. So in looking at this then, I'm really just going to like shade up here. I'm going to continue to go this direction. And then I also know that I need to go this direction here because of all the little arrows that I've drawn. So really I just have like this little sliver of white space, and otherwise the rest of this is kind of filled in. And that was because this was an OR. So that's kind of how you can use like one graph to help you filter out, you know, what your answers are. So let's look at a few more. Okay, so now I want to kind of pivot here, and I want to give you a little more practice with this, but I want to show you another thing that's really common with these types of problems. So let's do this one together, and then the next two you can try on your own. So the problem in question here is this y is greater than or equal to 4. So for this one, so this is asking you to really graph y equals 4. That's kind of like the line that you want to start with. So remember what this means. This means that no matter what you choose for your x's, so for instance, if I choose x equals 0, your y still has to be 4. So I've got this 0.04, or if I was here at x equals 2, so if I was here at x equals 2, my y still has to equal 4. So it doesn't matter what x's you want to choose, but your y has to always equal 4. That's what that literally means. So there's kind of the line that I'm starting with. And then if I want to actually graph this out, so now notice that this is greater than or equal to, so does that mean a solid line or a dotted line? That means a solid line like this. Okay, and then how do we get to the y is greater than or equal to 4? Well, this is actually a bit easier, I think, to graph, because where is the y going to be greater, on top or on bottom? Well, these values here are going to be the greater than, so I'm just going to note this here. Now, if you didn't like that trick that I just showed you, that you can kind of just really figure it out by looking at the graph, you can still use that method of choosing like 2 points. So for instance, if I chose the origin and tried to plug this in, so I would just plug in 0 is 0 greater than or equal to 4. That would be false. So you know that this side you do not shade, it would be this side up here. But I think just by kind of looking at this and thinking about which side would be larger, these values of y are going to be larger up here. And so notice I've just kind of drawn my little arrows in this case. And now let's pivot to the other line. So I'm going to draw this other one. And so I've got the y-intercept of 1. I go down 2 over 1. And then for this one, I'm going to have a dotted line like this. And now I have to figure out what side do I shade. So if I take this point here, this is negative 2, 0. So I plug that in. I'm going to get 0 is less than negative 2 times negative 2 plus 1. And if I work that out, I will get that 0 is less than 5, which is true. So I'm pretty sure I'm going to shade this side, but let me just double check by choosing another point on the other side. So this is 3, 0. So this is going to be 0 is less than negative 2 times 3 plus 1. So this is 0 is less than negative 6 plus 1. So is 0 less than negative 5? That is false. So this side is the false side. So this side here, I'm going to draw again my little arrows. So this would be the side that I would normally shade. However, this is an and problem. So now, investigating kind of all the parts that I would have shaded, where do they actually intersect? Well, they intersect in this little triangle right here. And so I can just kind of figure that out again by eyeballing it. So, you know, you do you on this one. If you feel like you cannot eyeball this and you want to draw, you know, the multiple graphs to be very sure, then do that. So do whatever you've got to do to actually make this work for you. Okay. Okay, so for this problem, I want you to try this. So let's start by just having you graph this x as less than 3. Do that first and then hit play when you're ready. Okay, so in this case, so this would mean that no matter what you do, x just has to equal 3. So I'm actually going to have a vertical line, and it's a vertical dotted line. So I'm trying my best to make this clear. Hopefully you can see this. So I've got this line right here at x equals 3, but it's a dotted line. Now, where are my x's actually less than this? Well, that would be to the left. So I'm just going to draw those little arrows there for now, and we'll just pivot to the next problem. Okay, so this one, we're going to have to get into that slope-intercept form type ordeal. So maybe you want to go ahead and get that into slope-intercept form and then see if you can graph it and hit play when you're ready. So I've got 4x minus 2y is less than or equal to 8. So I'll go ahead and subtract off the 4x. So I have negative 2y is less than or equal to negative 4x plus 8. And now notice I'm dividing by a negative, which means that my inequality has to flip. So much fun. Okay, so now I can go ahead and graph that. So let's see, that's a y-intercept of negative 4, 1, 2, 3, 4. And then a slope of 2, so I'm going to go up 1, 2, and over 1. Now in this case, this will be a solid line, and now I just have to figure out which side I'd want to shade. So let me clear some space. Okay, so I'll start, of course, with the origin. And oops, I accidentally got rid of that equation that we were working with. That's okay. So I'm going to plug in 0, 0. So I get 4 times 0 minus 2 times 0 is less than or equal to 8. So that says 0 is less than or equal to 8, which is true. So it sounds like that's the direction I want to shade in, but just doing an extra check. Let's see, 1, 2, 3, 4. Let's see, it looks like 4, 0 will be on the other side of the line. So I'll take 4 times 4 minus 2 times 0 is less than or equal to 8. So this is 16 is less than or equal to 8. So that is definitely false. So now I can see that I want to definitely shade in this direction. So now that we have a sketch of everything, now we want to take the fact that this is an OR problem into account, which means that we just really shade everything, right? So in this case, I can see which directions I need to shade in, so I can just go ahead and shade, 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 shade all around like this. And so we are good to go now. So that would be the answer. All right, so I've got one more here. And so this one at least is already in slope-intercept form. I highly recommend that you pause the video here and just try this one all the way through, and then hit play when you're ready. So starting with x is greater than negative 1. So here's negative 1, and I'm just going to go ahead and mark this line, x equals negative 1. Now where x is greater than negative 1, that's going to be to this direction here. Okay, so now moving on to the other line. So this one's already in slope-intercept form, which is nice. So I've got my y-intercept of 2, and then I've got a slope of 2, so I'll go up 2 over 1. And this one's going to require a solid line. So now I just have to figure out which side of this do I want to shade. So starting with 0, 0 as my test point. So I'm just going to plug this in. This is 0 is greater than or equal to 2 times 0 plus 2, which will give me that 0 is greater than or equal to 2. So that is false. Versus if I go to the other side, so let's see, 1, 2, 3, 4, this is negative 4, 0. So if I plug this in, this is 0 is greater than or equal to 2 times negative 2 plus 2. So this will be 0 is greater than or equal to negative 4 plus 2. So this is 0 is greater than or equal to negative 2. That is true. Okay, so that means then I want to shade on this side of the line. And so now as I kind of look at what I've got left in my graph versus this is an and problem, so I'm really thinking about where do these overlap. And the overlap's going to happen at this little space right in here. So this little sliver would be our answer. And so this was kind of a longer video, but hopefully it was helpful. I tried to provide a lot of examples. Any questions, you guys can always drop me a comment. Thanks for watching. I'll catch you next time.